how 3D Experience integrates the geology within the design of a civil infrastructure, how to quickly iterate in your tunnel design with a parametric model that provides you quantities per geological layers. I am Patrick Fougeret, CATIA Technical Specialist for Civil Engineering, and I will show you how to quickly create a simple parametric tunnel that will handle the different geological layers. I have here a simplified 3D geological model that can be either imported using our geology converters like SURPAC or OMF for open mining format, or designed using the 3D Experience Geology Modeler. I have 4 different polyhedric volumes that have been published. I will first insert an extended product under my project site and search for tunnel. I use the underground tunnel, set it as large range, and insert a 3D shape that will contain the 3D geometry of my tunnel. I will use the Civil 3D Design application and will first create an alignment. You can either use the road or railway tabs depending on your project. I click on horizontal alignment, check the different parameters of my road, a road with 2 lanes, and validate. For this example, I will do a really simple straight alignment, but it can be of course a lot more complex than that. The start stationing can be modified, and the stationing display will be automatically updated accordingly. Right now, in visualization, I can see that the right-of-way of my project is displayed with the 2 blue lines. I edit the start point and switch it to start of tunnel. Now, the display has automatically switched to the representation of my tunnel with red lines. I can now switch to the profile view, the vertical alignment. During the creation, I can add my geological layers that I want to display in the vertical alignment view. In here, you can change the line type or define if you want the geological layers to be filled or not. Now, I have my profile view with all the layers that I have selected. They are filled with the color inherited from the 3D. In Visualization tab, I can also display the labels of the layers. I will also create a simple vertical alignment by defining the start point and applying a gradient of -4% till the end. The tunnel contours are also displayed in red, and I can define the dimensions of the preview in Excavation and Filling command. I click on plus to create a new excavation and filling, and I can set the radius of the tunnel and the vertical offset because usually the vertical alignment is not at the center of the tunnel. By clicking on Compute, I will generate a preliminary cut and fill analysis based on the tunnel cylinder and an extrapolation of the 2D geological layers. I am getting 2 preliminary excavation volumes, one for each geological layers impacted by the tunnel. In View, you have now a new capability to display both horizontal and vertical alignments on the same screen with the horizontal split. If you navigate on one of the alignments, you can visualize the cursor positioning on both alignments to better understand your location. In Alignment Information, you will be able to display information on the position of your mouse, such as the distance to the ground surface or any geological layer. This is really useful to check the position of the tunnel upper or lower surfaces relatively to any geological layer. I can now generate the 3D alignment. If I hide the geology products, you can see that only a portion of the layers has been imported in my tunnel part based on the right-of-way of my project. This avoids bringing too much reference data in the tunnel part and allows improving performances. Now I will create the cross-section of my tunnel. In this command, I can create a global cross-section or left one or right one. I will use global. I select my 3D alignment as support. By default, the road surface is deduced from the alignment and set as input also. I could also add terrain or geological layers as input, but it is not necessary for my parametric tunnel. The crown shape of my road surface, which was set as input, is displayed as reference. I will first create a couple length parameters, such as the tunnel width the tunnel height. And finally, I will create a Boolean parameter that will allow me to drive the configuration of the tunnel between two options, a D-shaped tunnel or a cylinder. I will create first a D-shaped tunnel with points based on my road surface. In the Cartesian point mode, I can set an horizontal distance from the reference point and a vertical distance. You can use a naming convention for the points based on the drop-down menus or create your own name in the role field. The selected point will automatically be used as reference for a new point. Here it will be the right side of the D-shaped tunnel, so I can use a formula to link it with the tunnel width parameter. Same way, I create the left side of the tunnel. Then I create a point for the top of the tunnel with a formula linked with tunnel height and width parameters. Same way, I do the right side. And then I do the same at the center. That will be the origin of the half circle on the top. Usually, we use the cross-section profile command to create the geometry. But it does not handle circles well, so I switch to Wireframe and Surface tab and create first a polyline through the points, and then I create a half circle. Finally, I join them together. I can go back to the cross-section tab and use the Choose element that will allow me to switch from one configuration to another. I set the output type as drainage earthwork so that the application knows that material will be removed inside the shape of my tunnel. And then I can associate the activity of that geometry to the D-shaped Boolean parameter. It means that the geometry will be activated only if the Boolean parameter is set to true. Else, I will create another geometry to be used, a circle this time. I create a point for the circle center, and then create a circle. Set a formula for the radius linked with the tunnel height parameter. Now, I will edit the drainage earthwork and select the circle geometry as alternative. So when D-shape parameter is set to true, the D-shape contour is selected as drainage earthwork, the purple contour. If I set the parameter to false and update, we can see that the circle contour is set as the drainage earthwork. With the cross-section contextual menu, I will manage the inputs and add my three parameters as inputs. This way, I have a parametric cross-section driven by three parameters and an alignment. Now, I will generate the excavation 3D envelope of my tunnel. I use the road subgrade command, pick the alignment, select the cross-section I just created in the global section field. I can adjust the parameters of my cross-section. And when I click on OK, the 3D volume of my tunnel is created, which is typed as drainage earthwork. It is stored inside a road set that I can edit to add the geological layers so that my tunnel volume impacts the geology. I select the 4 geological layers in the geology field, click on Create Excavation and Filling Works. I do not need to keep non-connected excavation and filling works, which is used for road railway excavations. When I click on OK, 4 excavation works have been created for the different geological layers. Excavations for the geological layers that are not crossed by the tunnel are empty. For the 2 impacted, a volume has been created and each of those have beam quantity attributes that have been calculated for the volume. I can explore different alternatives when editing the road subgrade command, such as a cylindrical tunnel and a different tunnel height value. We see that the purple cross-section automatically updates. When clicking on OK, the tunnel volume and the excavations are automatically updated. Beam attributes have also been updated automatically. I can also modify the horizontal or vertical alignment. Here, I delete the gradient constraint and change the slope of my tunnel. When clicking on OK, my tunnel volume and excavations are automatically updated. So you have seen how easily we can iterate with a parametric tunnel and get important information such as quantities per geological layers in our model. Now, we can review the dataset by using the new cross-section viewer that will display the cross-section at a specific stationing. We see the elevation of the road surface points, the width of each lane, and the slopes with the geological layers in the background. We can also play the alignment to visualize the different geological layers that the tunnel will cross along the alignment. Finally, I can create a drawing. Using the multidiscipline drafting application, I can create an alignment view based on the vertical alignment. There is a dedicated tutorial for alignment drawings, but here I want to show you that we will get the different geological layers with their predefined colors inside the 2D. You can now create your own tunnel and explore quickly different alternatives to converge to the best solution for your project.